This conference is brought to you by CallStack, your React and React Native development experts.
All right, awesome. Hi, React Universe. It's great for us to be back here today. I see a pretty packed room, lots of people from the community interested in sharing and learning about how we can make React Native and the ecosystem a better place. So my name is Khalef Hosany. I'm here with Vladimir Morozov. We're both joining you folks from Microsoft in Seattle. And we're here to talk about a concept that we've been very passionate about for a few years, and that's Node API. So first, just a quick check. Like, how many of you have actually heard about Node API before?
Oh, wow.
All right, quite a few people. And how many have a good sense of how it actually works? Yeah, a little bit less. OK, but that's good. So great. We'll learn something together today. So Node API is an industry standard set of APIs that enables powerful extensibility within Node.js. So we will discuss how it can enhance the React Native ecosystem as well. And as we go on that journey, so imagine a world where essentially if you're a module or library developer, you can compile your module once and have it working against multiple versions of React Native without having to recompile it again. In a world where you can write your modules in any language of your choice, things, C, C++, Rust, whatever you're interested in. And the ability to combine the power of Node.js today to React Native and reuse the native modules that were originally designed for Node.js, but in React Native. And the ability to run the greatest and latest version of Hermes against older versions of React Native. So is that even possible? And the answer is yes. Teaser, so we're going to talk about this, about how Node API actually makes this possible. So it's a core component that we're thinking of integrating into React Native, and it enables us to do this. So what we'll do is we'll talk about the main concepts of it and the work that we've done in Hermes for Windows and React Native for Windows related to Node API. And then we'll go ahead and end with some demos. And this talk will help you understand some of the investments that have been happening in the community recently. And about a month ago, for example, CallStack published a blog announcing Node API support for React Native. And that was a tremendous effort from a lot of very smart people, which is very promising for the future. If you've been looking at the agenda as well, you'll see that tomorrow there's a second talk about Node API. That's going to be from Crane. And these two talks are complementary. So we would highly recommend that you actually watch Crane's talk as well. He will go into more details on the integration of Node API with React Native. OK, so with all of that said, what is Node API? So it is a set of APIs that was introduced around April of 2017. So a little bit more than 8 years ago, and it's been continually evolving and improving since then. The PR description helps give a sense of what this set of APIs is actually all about. And it's interesting to try to unpack what is actually being said there. So first, you'll see that there's a mention of an API or NAPI. If you've heard about that before, it's the old term that was used for this set of APIs. Since then, people have been calling this Node API, and that's a term that's persisted since then. It is built to work across different Node VMs. What does that part mean? So VM in this context is the virtual machine that is running your JavaScript, so in a sense, your JavaScript engine itself. And so what this means is Node API was a set of the APIs that was designed from day one to support different JavaScript engines within a hosting surface. So think of being able to support V8 or JSC as an example. And it supports building native modules, which lets you write native code, project it into your JavaScript environment, and be able to call that code from JavaScript code. So very similar concepts to what we have in React Native with turbo modules, expo modules, nitro modules, and so on. And it is a set of ABI-stable APIs to give essentially a set of guarantees so that the modules that are built using one version of Node API can continue being supported by newer versions as they are introduced without needing to recompile those older modules. And so let's talk a little bit more about an ABI-stable API. What does that mean? So ABI stands for Application Binary Interface. It strictly defines a set of rules and conventions that shared libraries can interact with each other. So this includes the calling conventions for your functions, the way data is laid out in memory, the way memory itself is allocated and deallocated, and the way errors are handled. And an ABI-stable API is a set of APIs that follows such rules, but also guarantees that there are no breaking changes when new versions are introduced. So for example, once a set is defined, methods are never renamed, methods are never deleted, which then guarantees that it keeps working even when new versions are introduced. If you think about like the Windows ecosystem, for example, people have built apps, like years or even decades ago, and they continue working on newer versions of Windows because of those types of guarantees. So with that, we'll go through some of the APIs that exist to give you a sense of how they're actually designed. And I'll hand over to Vladimir to do that.
OK, on this slide, we see just as an example 3 different functions. One of them creates object, gets object property, and sets object property. All Node API functions, they receive Node API environment as the first parameter. They work with Node API values, and they return Node API status. Status can indicate success or failure. In case of error, we can use this function to get additional error information. Node API functions can throw JavaScript exceptions, and to handle JavaScript exceptions, we can use these 2 functions. So we just kind of small example set of functions. We overall have more than 100 different functions right now in the set, and it's growing. Node API values, they just pointers to JavaScript values located on a special stack. We have a few functions to handle this stack. We can open and close scope. All the stack gets completely emptied every time we complete call to native module. To preserve values between calls to native modules, we're using global ref-counted values. Unlike normal ref-counted values, they must be explicitly deleted. Then ref-count becomes 0. It just becomes like a weak reference. All Node API functions, they split up in 2 header files. JS native API, it contains functions which consider to be runtime independent. They have set of functions to manipulate with JavaScript primitive and object values. They also have some functions which helps us to interop between JavaScript and native code. Functions in Node API.h, they're considered to be Node.js specific functions. It's just kind of quick example of a very simple Hello World Node API module. On the bottom, we see this special macro, which helps us to register the module. It calls this special init method. Init method can be used to initialize exports from our own module. You can think about like common JS modules. You have typically assign exports or return exports. So in this case, we just assign this say hello property, and we assign a say hello method, which we see here. This function, what it does, like first of all, we read arguments. We then convert first parameter from Node API value to string. We format return message. Then we convert this message to Node API value and return it. So we'll see it a little better later in action. So this very simple JavaScript, which exercises our module, it creates an instance of our module and calls say hello method.
Yeah, and so So thanks, Vladimir. So this is a like short walkthrough of a module that you can write in C, but actually Node API modules can be written in any language that can interop with C. So that includes C++, Rust, Go, lots of popular languages. There are multiple runtimes that are also supported. The whole list is maintained by the Node.js project, and so very recently, React Native was added as one of those runtimes that actually supports Node API.
So this is just a very simple example of using a C++ wraparound of Node API. With C++ code being supported also by Node.js project, the code looks much simpler than just using C, and it has a great interop with standard C++ library. It's just another example. The same code written in C#. You can see it's totally minor. The reason we have compile time code generation in all this different code, which we saw before, all this boilerplate code being automatically generated for us. So one of the most important concepts in Node API is about versioning. So version is just simple number. Current version is version 10. So every time Node API loads a new module instance, each module reports which version of Node API it wants to use. So each module receives its own Node API environment instance initialized with this version. So technically, each module has its own Node API environment instance. So what it allows us to do, like every time we produce new version of a Node API, yes, we never remove any existing functions, we never modify functions, but we can introduce new behavior. But module compiled, say, against version 8, even we have already version 9, 10, and so on, this module will be loaded in new version Node.js and continue to behave and work exactly the same way as before without any recompilation. So module compiled, which like 10 years ago, will continue to work today. So
just as a quick summary, pretty quickly, so Node APIs, it's a C-based set of APIs. It has strict rules about supporting ABI-stability. It can introduce new behavior when new versions are introduced. And it's actively supported by the Node.js Node API group. And that's a group that meets once a week that Vladimir is a member of as well. You're welcome to join it too if you're interested to contribute to the effort. So let's talk a little bit about how we did this for React Native Windows. It was actually like bringing Node API in was actually part of our very initial vision because of some of the unique requirements we had. So we wanted to support multiple JavaScript engines within React Native for Windows. Like Hermes was getting stood up back at the time. We were using V8. We were using Microsoft's engine called Chakra. And we also had developers who were going to use multiple languages. So in particular, they wanted to write in C++ and in C#, which is common for Windows. So we chose Node API as the way to interrupt between this native and JavaScript code, as it is the de facto industry standard for doing so, which is usually better than trying to reinvent new APIs from scratch. And to enable JSI to work with it, we built a JSI runtime implementation for Node API. This work started around May of 2021. We had some discussions with the Hermes team around this. And then in 2022 was when Vladimir introduced the first implementation in the Hermes fork that we have for Windows. A couple of years later, we started that work to upstream it to the main Hermes repo. And then we started seeing some interest as well in the React Native community. For example, Jamie Birch had a talk recently about this. And as I was mentioning earlier, in 2025, ColdStack started sponsoring work to enable Node API for React Native. And the way it works is pretty simple. So it works on top of the existing Hermes APIs. So it's very similar to the way JSI is implemented. There are two files that contains the implementation. there's a header file and a CPP file that you can take a look at with the link that we provided here. And then to guarantee that it's actually working well, what we did was we brought the tests that are run in the Node.js repo to run against the same environment. So those tests are written in JavaScript. They exercise the APIs and make sure that all of their work versions are working based on their specific and unique behaviors. And then in order to be able to run those tests, what we did was we created essentially like a Node Lite process, which internally uses Hermes as the JavaScript engine. It's not a full JS runtime, but it implements what we need in order to be able to get those tests to run properly.
So this is just a quick example, one of the functions how we implement Node API get property. So this function just checks and some preconditions, postconditions. We check that some input parameters are not null. We establish some JSC scope for values used by Hermes engine. Then we just ensure that we're working with object. We check its result. We get in object property, checking result, and when we establish a result value on our return call stack and return value. So it's very kind of simple code, and as you see, it's very, very thin wrapper on top of internal Hermes API. So currently, what we do inside of React Native for Windows, we have JSI wrapper created on top of Node API. Going forward, what we want to do, we want to enable JSI and Node API working side by side. And especially for ABI-stable scenarios, we want to enable interop with Hermes ABI-stable JSI that Hermes team recently introduced. Recently, probably 2 years ago. This is an example of our JSI wrapper for Node API. So we have this function, create array buffer. This function uses Node API function, Node API create external array buffer. And you can know that it only compiles if a JSI version more equal to 9. And you may ask where is version 9 coming from. So what we do, we actually look for all changes to JSI, and we assign version to some commits, some specific commits or group of commits if they go next to each other. Then we maintain a list of how these JSI versions match to versions of React Native. Because different versions of React Native using different set of JSI functions. So this way, we're using exactly the same Hermes DLL and JSI wrapper on top of it, across multiple versions of React Native for Windows. Everything what we do, we're just changing this small JSI version macro value. This way, even we have some of our applications running very old React Native, maybe like 1 or 2 year old, we can still use latest and greatest Hermes engine and benefit from all these changes to performance, improvements, and so on. Okay.
All right, so we're going to go through some demos to show you how that all comes together. So while Vladimir is getting set up, there are 3 main things that we're trying to show. One is looking at a simple Node API module in code, like how we're actually writing this, and running them within different environments, and then using multiple languages. Okay, so I'll hand over to you. Yeah.
Great. This is just a very simple demo project, and this is exactly the same code we saw earlier on the slide. If you look a little bit here, we have this Node API module registration. I just want to show that then this macro get expanded. Internally, we're going to have 2 different functions. One of these functions called Node API module get API version, v1. And it returns value of Node API version macro. By default, it's version 8, but in your code, you can specify this macro to be version 9, version 10, or whatever upcoming version 11. It also has this function called register module. This second function, it's kind of starts to initialize your module. And pretty much every time we load DLL, we're just looking for these 2 functions inside of Node.js. So let's just see this code in action. It's very simple. We just say node hello.js, and we're running this code. So we say hello world, and we also print some additional information with version of v8 and current executable and DLL file. DLL is our module. We can run the same way. It's from Hermes. So we have JS engine Hermes, the same result. Just a quick change here. Like this is our hello.js functions. Like I said, it's just say hello world. We printed message a bit. We printed some additional information. And Hermes CLI, what we mentioned here, it's what we've done for this demo. We just took whatever Node Lite process we're using for testing of Node API. We modified it a bit just to kind of work here. So we can exercise our Hermes engine. Just to make it look real, let's change code and recompile it. Hopefully it works. So we changed, instead of world, we're saying React Universe 2025. And let's also change our code over here. Say instead of hello, say something like more friendlier. We're friends, right? And over here, we say, so to compile code, we just need to run npm install. Computer is offline, it's just taking a little bit of time to connect to something which doesn't exist. So meantime, let me just open this binding.zip. This is kind of build file used by Node.js. And you see it's very simple. We just specify a target name and specifying files which we want to compile. It's our module plus additional C++ file which gives us information about DLL and executable file. So it's all compiled. Let's try to run it. Hello. Hey, React Universe. The same. The same can be done from Hermes. But wait, there is more. Like we can do Deno. And if we were adventurous, we can also do Bun. Same result.
Yeah, so that's pretty cool. That essentially shows that you can have modules that are written and running within React Native. You can take them and actually port them to different JavaScript execution environments and run them there as well. Cool.
So in this example, we also have the same code in C++, and we also have the same code in C#. For the sake of saving time for our presentation, I not run this code, but let me just show that in C# we have this very, very simple code. But if we start to dig a little bit into kind of some compiled code, we go to this release, generated, and then we can see this generated file for us. What we do in C#, pretty much the same. We're creating this Node API register function, like we export it, and we have pretty much the same code we write in C++ or C. We're kind of creating these two methods, say hello and print module info, and then we have this special wrapper which converts Node API values to strings and vice versa. So all this magic, instead of writing ourselves, will just been generated for us.
Cool.
Let's go back to slides.
Yeah, so and all this code is available online as well. So if you want to try it, play with it, see how it works, there's some we have a lot of documentation. You can just do that and try it out. And if you have any questions, of course, reach out and let us know. So when we were talking about this earlier, we were saying, like we can imagine a world where there are a few things that are possible. So where are we actually with this? So first, like, can we use precompiled modules against different versions of React Native? Yes, that's supported through Node API. Again, take a look at Crane's talk tomorrow, because he will go into more details about those universal modules. And can you write in your favorite language? If you're using Node API, yes, because like it supports any language that can bind to C. And can you use Node.js modules in React Native? So not quite. Like this one still needs some work. But supporting Node API within React Native is the first step to actually getting there. And then the latest version of Hermes, yes, we're already doing this today in React Native for Windows. So we're marching slowly towards all these goals. It's a long journey, but it's one that we strongly believe can bring a lot of goodness to the ecosystem. Okay, so with that, I just want to say a huge thank you for taking the time to listen to us, whether you're in person or online. And these are some of the links that you can go to in order to learn more about Node API and its integration in Hermes. And then again, thank you once more, and have a great rest of your conference.